outstanding Honorable Vice Chancellor, respected Director General of Geological Survey of India, Registrar, Presidency University, distinguished alumni, guests from GSI, esteemed faculty and staff members of the Department of Geology, Presidency University, respected attendees, and my dear colleagues. I am Pramita Ghosh.
And I am Amar Rai. It is an honor and privilege to welcome you all to the Geological Institute Conference GIC 2024, organized by the Geological Institute, Department of Geology at Presidency University. This conference is aimed to celebrate the birth centenary of Professor Ajit Kumar Saha. Professor Saha was one of those rare personalities in the earth science community in India whose name became synonymous with the total dedication to science.
Let us honor Professor Ajit Kumar Saha's memory by approaching this conference with the same passion for discovery that he instilled in his students and colleagues. It is our pleasure to extend a special welcome to our esteemed dignitaries who have joined us today. Your presence enriches this event and inspires the next generation of geologists to strive for excellence.
To start this momentous occasion, we would like to invite on dais Professor Nirmallo Narayan Chakraborty, Honorable Vice Chancellor, Presidency University. Please, sir. Sri Ajit Saha, Director General, Geological Survey of India, our guest in chief. Please, sir. Distinguished alumnus and mentor, Professor Dhrubajyoti Mukhopadhyay, our guest of honor. Please, sir.
Dr. Debojyoti Konar, Registrar, Presidency University. Professor Arijit Ray, Head of the Department of Geology and President of the Geological Institute, Presidency University. Professor Shantanu Bose, Convener GIC 2024. Sir, I will request you all to your respective chairs. Thank you, sir. I now request my colleague, Auritra Roy, to kindly present a token of appreciation to our Honorable Vice Chancellor, sir, as a gesture of her gratitude.
Now I request my colleague Ahona Chakraborty to kindly present a token of appreciation to guest in chief Sri Ajit Saha, Director General of Geological Survey of India. We are privileged by his presence to grace this occasion in spite of his busy schedule.
I request my colleague Bornali Bhakta to kindly present a token of appreciation to our guest of honor, Professor Dhrubajyoti Mukhopadhyay, an esteemed alumnus and mentor of several generations of our department.
Now I request Auritra Roy to kindly present a token of appreciation to Honorable Registrar of Presidency University, Dr. Debojyoti Konar. Without his wholehearted support, organizing such a program in a short notice is simply impossible.
Now, I would request Ohana Chakraborty to present a token of appreciation to Professor Arijit Rai, Head of the Department of Geology.
Now I request my colleague Bornali Bhaktar to present a token of appreciation to Professor Shantanu Bose, convener of GIC 2024.
Thank you, everyone. We will begin our conference by lighting the lamp of knowledge and wisdom. Before that, I would request the dignitaries to offer some flowers in front of Professor Saha's portrait to honor him today. Thank you, everyone. Now we invite all the dignitaries present on the stage to formally start the GIC 2024 by lighting the lamp.
Hello.
Thank you everyone. Now I would like to call upon Professor Shantanu Bose, convener GIC 2024, to give his welcome address. Please, sir.
Good morning to everyone. Honorable Vice Chancellor, sir, Guest in Chief, Sri Ajit Kumar Saha, Guest of Honor, Professor Dhruvajyoti Mukhopadhyay, and other dignitaries on and off the dais, my colleagues, and my dear student friends. On behalf of GIC 2024, a very warm welcome to you all to this one-day conference dedicated to celebrating the birth centenary of our beloved teacher, Professor Ajit Kumar Saha. In honor of his legacy, we have chosen to commemorate this milestone through Professor Saha's philosophy of living, a commitment to academic pursuit for a better future. The primary goal of GIC 2024 is to provide a platform, particularly for geology research students across the country, to interact with each other. We are pleased to report a very strong response in a very short notice from several universities and institutes across the country, receiving around 85 abstracts covering almost all branches of geology. Bringing together around 100 young researchers from all over the country is a fitting tribute to Professor A.K. Saha's enduring vision. We believe it. Today I take this opportunity to thank everyone who enthusiastically responded to our call, to our initiative. Moreover, I am happy to announce today that the Geological Institute of Presidency University plans to continue this one-day conference as an annual event dedicated to research students. I look forward to the exciting scientific sessions and hope all the participants will engage in enriching discussion with each other, and also you will take the scope to interact with experts here. I am very happy we are having another event today. We are also fortunate to witness another significant event today, the signing of MoU between the Geological Survey of India and Presidency University. This agreement marks the beginning of a new phase of academic collaboration between two institutes. Geology education, in fact, owes much to the Geological Survey of India, and it was here at this institute, previously named Presidency College, the GSI laid the foundation of teaching this discipline. Today, MoU signing ceremony will further strengthen the bond between the GSI and our university. That's all I wanted to share today. Welcome you all again to GIC 2024. Thank you very much.
Thank you, sir, for sharing the highlights of the conference. Additionally, you have offered us another occasion for celebration today, the MoU signing ceremony between the Geological Survey of India and Presidency University.
It would be an honor to call upon Honorable Vice Chancellor, sir, Dr. Nirmala Chakraborty, to kindly say a few words.
Good morning, everybody. On behalf of Presidency University, I welcome you all to this very happy occasion. Presidency College, as it was known those days, is indeed blessed with quite a few distinguished researchers, committed teachers, and Professor Saha, whose birth centenary is being celebrated here today, is one of those luminaries. So it is indeed a very fitting way of paying tribute to this great scholar by organizing this event. And today this event is even more special for us because today we will be signing an MOU with Geological Survey of India. This MOU was long overdue, but ultimately we succeeded in formalizing the whole thing. So on behalf of Presidency University, I extend my sincere thanks to Professor Saha, under whose leadership we have been able to enter into an MOU with GSI. So hopefully, both Presidency University and GSI will be, cooperating with each other, and our research scholars, our teachers will be greatly benefited by the, infrastructural and other logistic assistance that will be provided by GSI. So once again, I welcome you all, and we all look forward to the series of, lectures and discourses that we'll be having today here. Thank you very much for joining us today. Thank you.
Thank you, sir, for your inspiring words and support in making this event successful.
I would now ask the guest in chief, Sri Ajit Saha, Director General, GSI, to kindly address the audience and say a few words.
Good morning, everyone, and dignitaries on the dais, off the dais, and my friends and colleagues, and the budding geoscientists who are flocking together. I am very, very much happy and elated today. And firstly, because of the fact that I am sharing the dais with Dr. Dhruva Mukhopadhyay. This is something unthinkable for me. I am standing in the Diro Geo Hall, Presidency College, erstwhile Presidency College, addressing you. Once again, something unthinkable has happened. And then again, I'll be going into a collaboration with Presidency University to take our goals forward. So many events, so many exhilarating aspects of today's gathering. I'm definitely overwhelmed. I am representing Geological Survey of India. Still now, quite probably, it is the largest employer of geoscientists in India, still now. Apart from the academia, of course, the professional agency, sort of national mapping agency, which employs geoscientists. And we are bound by certain rules and regulations and certain mandates within which we have to work. And that may seem a little bit mundane and ordinary to many of the people because we go on doing similar type of work year after year. But within that, we try to find areas and avenues where we can excel, where we can innovate. We too have aspirations, and these aspirations to innovate and to excel is leading towards this collaborative journey which we are going to have with Presidency University. Because we need new blood, new thinking, new ideas from you people. As we are bound by mandate, you are not. We need this new thinking to incorporate us and rejuvenate us. We have already existing MOUs with most of the IITs. We have very fruitful programs, collaborative programs going on. And we want to have similar sort of programs, collaborative programs with you people. We, Geological Survey of India, for that matter, we are like leeches. We want to suck energy from you. your energy is boundless. We are a little bit jaded. So new blood coming into GSI rejuvenates GSI. And if GSI gets rejuvenated, the whole ecosystem, the whole geological ecosystem, the geoscience ecosystem in the country gets rejuvenated. So it's a mutually beneficial exercise, and I hope we will be successful in this endeavor. I have many of my colleagues sitting here who also voice the same ethos, and of course our professor Dr. Dhruvo Mukhopadhyay, who has been the doyen of geosciences, and I mean, what can I say about this? And the person whom we are commemorating today, Dr. Saha, he is known to everyone, even though they are not alumni of Presidency University or Presidency College for that matter. He is known to everyone. He is the most revered person in this field of studies. And I was not an alumni of this college, but we had shared classes. He taught us geostatistics. And those are really, I mean, days and moments filled with nostalgia. Can't express it in words, very difficult to express it in words. There are many people who are sitting here who has come into the contact of Dr. Saha. They know what a person he was, dedicated, absolutely dedicated to the science of the earth. So I don't want to spend much time talking in this manner. There are a lot of things which are waiting to be done, to be heard. So wish you all the best for the proceedings which are going to happen. And as I said, I'm very much happy that we are going into the collaboration, and we want new ideas from you people. We'll work together, we'll do something great. Thank you very much.
Thank you, sir, for your kind words and suggestions. Your presence has made this event even more meaningful for the geology students and research scholars of Presidency University and all other attendees of GIC 2024.
Now, I would like to invite the guest of honor, Professor Dhruvo Mukhopadhyay, to kindly address the audience. So please, share your thoughts.
Principal Professor Nirmal Chakraborty, Director General of Geological Survey of India, Ajit Saha, my friends, Shantanu and Orijit, and the Registrar, Professor Devajyoti Khanna. It is a great honor and privilege for me to speak here in a meeting for paying tribute to our teacher, Professor A.K. Saha. My acquaintance with geology dates back to 1953, when I joined the Presidency College in the intermediate science course and took geology as the fourth subject. We didn't have Professor Saha as a teacher then. Professor Arun Rai and Professor P.K. Datto, they taught geology in the intermediate science courses. But we had a one-day fieldwork season twice, in the first year and the second year. And Dr. Saha went with us to the field. And there was a batch of 63 students, and 4 teachers accompanied them. We went in the first year, as far as I recall, we went to Asansol and Maithon, that area. And in the second year, we went to Sahibganj to study the Rajmahals. And in both the trips, Dr. Saha joined us. Even then, we could see that how Dr. Saha, with his erudition, could explain things in a very simple way to a novice in geology. That was the beauty of his teaching. His teaching apparently was in simple language, and he was not a very great orator, but it was what he taught was very systematized and came in small packets. But what he taught was contained the most recent literature in that topic published then. So when he studied granite, Dr. Saha's class would treat the subject of granitization, which was a hot topic, controversial topic in those days. So in this way, there are many examples of where Dr. Saha was very up-to-date in his teaching, but this was taught in a simple language, understandable to the undergraduate students as well as for the advanced researchers. And Dr. Saha had the uncanny ability to detect what is going to be the frontline areas of research in geology. So his doctoral thesis was on the granitization topic in Shingbum area, which was then a very frontline area of study. When he came back from Canada, after doing PhD work, working on the granites of Canada, then the geochemistry was making small steps forward. And Dr. Saha could foresee that in the coming days, the subject of petrology would not be confined only to the microscopic studies, but also to the study of chemistry of the rocks. So he immediately started a geochemical studies in Presidency College. Presidency College had very modest financial ability, but with that, that did not deter him. He set up a geochemistry laboratory with very simple instruments, flame photometer and the spectrophotometer, and could produce volume of data on the granitic rocks. Then after he produced a phenomenal amount of chemical and petrological data on the Shingbum granite, then geostatistics was then entering geology. And Dr. Saha immediately went into that. So he subjected his analysis, the chemical analysis, for geostatistical studies, and that was quite a novel thing in that at that time anywhere in India. So and then he was all along his life he was a student of hard rock geology. But then at that time, the consciousness about the environment and environmental pollution was just coming into being. A few people were talking about air pollution and environmental pollution. Dr. Saha, with all his life spending on hard rocks, he took up a research project on air pollution in Durgapur area. Just think about his foresight. And eventually that became one of his principal interests, and he set up himself an institute, Center of Study in Man and Environment, to study the environmental aspects of geology, pollution, etc. So he had tremendous foresight in his research. And just in a lighter vein, one of my senior Dada used to tell, Dr. Saha lived quite near in the Sitaramgo Street, and his address was 4C Sitaramgo Street. Then this Dada would say, it is not strange that Dr. Saha has such foresight. After all, he lives in 4C. So, but Dr. Saha, with his devotion to research, he was quintessentially a teacher also. He never neglected his teaching. We never saw him missing a class for research purposes. He used to go abroad or used to go outside Calcutta, but he would always make up his lost time in teaching. And he produced a whole bevy of students who have made their mark in India and abroad. And at that time, and he made, principally because of his efforts and the people who gathered around him, he made Presidency College a leading center of research in our country. So we used to proudly say in those days that everybody who is anybody in Indian geology is an alumnus of Presidency College. I hope the Presidency College, the present Department of the Presidency College will carry forward this tradition and produce students who will make their mark in geological sciences. I am particularly happy that a MOU is being signed between the Geological Survey of India and the Department of Geology, Presidency College. But the collaboration between the Geology Department and the Geological Survey of India is nothing new. It started from its very inception. The department was started by no less a person than Sir Thomas Holland. And through all these years, some legendary geologists of India like J. Dunn, West, Heron, Chibar, many of them, they taught at the Geology Department of Presidency College. We were also taught Indian stratigraphy by Professor Dr. S.P. Nautiyal coming from the Geological Survey of India. So this collaboration between Geological Survey and the Department of Geology has a long history. After us, I think we were the last batch where after us this practice was discontinued. And the Geological Survey officers did not come to teach the students of Presidency College. But I am happy that this MOU is being signed, so it will open up a new era of collaboration and advance not only the research capabilities of the department and of the survey, but will add to the fundamentals of our science. So with these words, I wish, finally I just wanted to say it is very fitting that this commemorative seminar is with the research scholars, because Dr. Saha was a scientist who always encouraged young students, young researchers in their work. So it is fitting that this seminar is being devoted to the work done by the research scholars from this department and from outside this department, from all over India. So we'll have I hope we will have a very fruitful session, 2 sessions, and I wish all success to the seminar, and thank you all.
Thank you, sir, for sharing your thoughts about Professor A.K. Saha. It is now our responsibility to carry forward the legacy of Professor A.K. Saha in the days to come.
I would now request Dr. Debojyoti Konar, Registrar, Presidency University, to say a few words.
Honorable Vice Chancellor, Presidency University, Professor Nirmalanan Chakraborty, DGCSI, Sri Ajit Saha, Professor Dhubajyoti Mukhopadhyay, teacher of all of us, head of the department, other DDGs, particularly Dr. Shiladitya Sengupta, and other DDGs of GSI, my dear students, and the geoscientists of presence in this hall, in this August gathering. So today is it's really an auspicious day because, say, the Geological Institute of this, particularly which is hosted in this Department of Geology of this university, they are holding their GIC 2024, and it's the birth centenary celebration started for Professor A.K. Saha, and on the same day we are going to sign MOU between GSI and Presidency University. So before signing this MOU on behalf of the university, I want to mention certain things. This was a long-term due. This initiative has started when Professor Prof. Das Gupta, who is present in this hall, I can see, was the registrar of this university. One day, I can recall, Professor Malavika Sarkar was the Vice Chancellor in chair. I was the Controller of Examinations at that time. Provida was a registrar, and in my presence, I can recall that Provida said that now it has upgraded to university from the college. We have to enter into, we have to go for a tie-up with GSI and others. And thereafter, the departmental teachers and other members of the department, faculty members of the department, other administrators, they tried, and finally, last week we got the permission. Now it is, permission is required from the state government before signing such MOU with any organization or university. So we received that, and I immediately informed our Vice Chancellor that, sir, we have received it, and he said that consult with the department that so that we can sign it as early as possible. And congratulations to the Department of Geology that they ultimately managed to do it with a very short time and on the same day. So with these few words regarding this, again I'm very glad to that we are very glad to sign this MOU with GSI, and I sincere congratulations to these organizers who have organized this great event. And so with these few words, thank you all.
Thank you, sir, for your presence and your support.
Before we hear from Professor Ajit Ray, Head of the Department of Geology, let us take a moment to witness the MOU signing ceremony between the Geological Survey of India and Presidency University, Kolkata. This is a significant moment for all the students and researchers at Presidency University, as it provides an opportunity for academic collaboration with the Geological Survey of India.
We would like to extend our gratitude to the Honorable Vice Chancellor, the Registrar, and especially the faculty members of Presidency University, along with the Director General of Geological Survey of India and his team, for the dedicated efforts in re-strengthening the century-old bond between our two institutions. The exchange of MOU will grant the involved parties the approval to undertake necessary activities as outlined in the agreement to collaboratively achieve the goals specified in the MOU.
Before the MOU signing ceremony, I would like to call upon Dr. Joyce Bakchi, ADG PSS, Dr. Soibal Ghosh, DDG and P&A, Sri Shiladitya Sengupta, DDG PSS, Professor Gautam Ghosh, Department of Geology from Presidency University. Please, sir. Now, I would like to formally request Sri Ajit Kumar Saha, the Director General of Geological Survey of India, and Dr. Debojyoti Kona, the Registrar of Presidency University, to exchange the documents regarding the MOU. We are very happy and excited to have this event today on this special occasion. Now, I request Professor Arijit Ray, Head of the Department of Geology of Presidency University, to say a few words. So please.
Good morning. Honorable Vice Chancellor Sir, Honorable Director General, Geological Survey of India, our guest of honor, Professor Debojyoti Mukhopadhyay, Honorable Registrar, all our faculty members, alumni, students, and participants for today's seminar. On behalf of Geological Institute, on behalf of Geology Department, Presidency University, erstwhile Presidency College, Kolkata, I welcome you all to today's seminar, that is GIC 2024, in the memory of our beloved Professor Ajit Kumar Saha. This year is the birth centenary of Professor Saha. It started from May 2024 and it will continue up to May 2025. And in this year, we have planned a number of events, and we have started with this one, that is a Scholar and Student Symposium nationwide. The idea initially was cropped from Prof Dasgupta, and after that we decided in our departmental meeting and meeting with our alumni that we'll go for year-wise birth celebration of this birth centenary. And this event, that is GIC 2024, I want to congratulate our scholars and students because they work really hard to make the event successful, and within a very short period of time. So it's a big achievement for us. And incidentally, we are also trying to make a collaboration, a move between Geological Survey of India and Geology Department, Presidency University. We applied for that, and the approval from the higher education has come just few days before. So we thought it would be great if we can do it simultaneously. So we are honored, we are privileged that we are going to sign a MOU between our university and Geological Survey of India and that will definitely enlarge the scope of studies in earth science for our students, scholars, faculty members. And Professor Saha, a legendary professor, as Professor Mukhopadhyay told, was a visionary, and he started mathematical geology, environmental geology. Actually, he planned it long before, and he was the first man in that regard in India who thought of these subjects well ahead. We are introduced to geology or earth science by Professor Shah because the first class we had here in 1980 was taken by Professor Shah, and the subject was Introduction to Geology. And since then we had the chances to be taught by him in undergraduate, in postgraduate, different subjects, and in postgraduate he taught us mathematical geology. He was the father figure of our department, a completely devoted and dedicated person, a loving person. So I feel proud, I feel privileged, I feel honored, and on behalf of our department, our university, I congratulate all of you to be present here today to give us support. Thank you.
Thank you, sir, for your inspiring words.
I would now request the dignitaries to kindly unveil the abstract volume of the conference. This act marks the official inauguration of the conference. Thank you, everyone. So I would request you to take your seat.
With that, the inaugural session of the Geological Institute Conference 2024 is concluded. We encourage all the attendees to participate actively in the sessions ahead and make the most of the opportunities to learn, share, and connect with the fellow researchers and experts. I request the volunteers to escort the attendees to the venues of the technical sessions 1 and 2, which will take place from 11 a.m. at NLT and conference room respectively.
As we disperse from here, please help yourselves with tea and breakfast outside the Delosio Hall. The attendees are requested to get their breakfast from the registration counter itself, and in case of any difficulties, feel free to ask our volunteers. Thank you, everyone.
2016, where you have described this. Yes. Okay. So in the full body domain, you have another one. You have a very similar kind of metamorphic textures, ultra-high temperature metamorphism, followed by significant structural details. And these are series of papers we have published here, which proves that you have again a very similar history with the Visakhapatnam domain, where you have very strong isobaric cooling dominated metamorphic history. So the last one is the Angul domain, where you have, which is situated northern part of the Mahanadi shear zone. And this is something new because we have discovered it in very recent time. One of our students, Apurupa, our PhD thesis and her work showed that you have two different events here. One is very old, 1.2 billion years history, and the other one is 1.0 billion years history. And this is something different from whatever we have learned from Eastern Ghats. And this is the story. This is the pressure temperature history. The first one is around 1.2 billion years. The second one is 900 to 960. So these are the compiled pressure temperature paths. We are seeing different horizons, different kinds of curvatures, and all these connect to one point that this is a very complicated history. But this is important to understand that there are two broad divisions. One is something around 1.0 to 0.9 and something around 1.2 billion years old. So this Angkor domain has been understood to have a different history from the rest of the Eastern Ghats. So if it is so, what is the role of the intervening shear zone, the Mahanadi shear zone? That is a story that we recently found, that the Angkor, this Mahanadi shear zone is represented by high pressure peak metamorphism and decompression vis-a-vis UHT metamorphism, and these are the important textures so far not identified within the heartland of Eastern Ghats. High temperature garnet bearing rocks, decompression textures and garnet breakdown textures to give this kind of pressure temperature path. This hairpin like pressure temperature path has not been discovered from any part of Eastern Ghats interior. So this is something new, and that gives a scenario that this is possibly the situation when it was around 900 million years back. So these are the positions of pressure temperature histories. These are fitting each other. But something is special here in this story is the occurrence of this Mahanadi shear zone, where you have a very strong decompression dominated part, which means that this is a proposed Grenvillian age sutures, because the age of this metamorphism is around 960 million years. So this is the proposed Grenvillian suture, which was never discovered from the heartland of Eastern Ghats. So now we have the dots joined in deep time. We have Platonic India here, and these are the part of Eastern Ghats. These are the part of Napier complex, Antarctica. And you have very close similarity of these two areas, so the dots are now coming very close to each other. So this is the conclusions, we should say. It's a Eastern Ghats is a complex domain with crustal domain showing contrasting pressure temperature histories, which apparently has a glaring similarity with that of the Rhino province. And this recent data show there is a presence of crustal domains within the Eastern Rhino province, so very similar to what is there in the Eastern Ghats. And the northern and the southern Rhino province have similar pressure temperature histories, but there are contrasting lithogeophysical characters, which is analogous to the Visakhapatnam and Fulbani domains with intervening this Nagavali Bangshadhara shear zone. The northern Angul domain has an older history, which is similar to the Pritsbe area, which collided with the Fulbani domain, resulting subduction of the later and formation of high pressure granulites in it. Rhino Eastern Ghats story is a complex, has a history of complex accretionary system which joined disparate blocks or domains and eventually juxtaposed with India against the continental East Antarctica by 900 million years. So that's all. Thank you.
Thank you very much. I need only one or two very quick questions. Anybody from scholar? Any questions? No questions. Okay. Thank you. Thank you.
Thank you. Yes.
Age of the Mahanadi shear.
The rocks we have dated from the Mahanadi shear zone, some mafic rocks, enclosed within granitic rocks. They have 960 million years of age of metamorphism. This is the zircon overload. So yes, but most of the low temperature events occurred around 500 million years because the argon dates are. It's a long man, old date. Proceed.
Now, technical session, our first speaker. Ajit Ghosh. Anuj Ghosh. And from IIT Kharagpur.
the system. It also causes rheological weakening of the rocks, which effectively raises the rate of deformation. As we all know, that the major source of partial melting in metamorphic rocks are the dehydration melting reactions of hydrous minerals like muscovite, biotite, and hornblende. Loss of melt is a very common process in natural systems. Partial melting normally initiates in the lower crust, but from there the melt usually migrates and may be emplaced at sites far removed from the source rocks. In granulites, melt loss is generally considered to have occurred until the metamorphic peak. However, some melt may also be lost after the metamorphic peak. With loss of melt, the rocks progressively tend to become more acidic in nature with decreased melt producing capacity. So these are the contents that I will be covering through. So partial melting initiates at the grade triple junctions with increasing degree of partial melting. These isolated pockets of melts start to coalesce and form interconnected networks along the grain boundaries. The amount of melting needed to form such networks depends the amount of melting needed to form such networks depends on the surface free energy between the solid and the melt and the interline. Once such a network is formed, the melt may eventually start to move as the system becomes permeable. For this, the amount of melt generated in the source rock must exceed the minimum amount of melt needed to satisfy the surface tension. Small grains are separated by melt. Drastic decrease in the aggregate strength of the rock due to increase in the proportion of the melt-bearing grain boundaries. Now, this is a snapshot taken from Brown et al. 2011. The purpose of showing this is to emphasize on the fact that tectonic stresses play a vital role in segregating and channelizing melts. Tectonic stresses are normally deviatoric stresses. Now, the evidence of melt loss in metamorphic rocks is manifested in the form of the preserved mineral assemblage. From the diagrams taken from White and Powell 2002, we can clearly understand that with increasing fraction of melt loss beyond the critical fraction, as shown as X dash in both the diagrams, the entirety of the peak metamorphic assemblage would be preserved upon cooling. In other words, melt loss inhibits or prevents retrogression. The process of melt loss in natural systems is generally considered to be cyclic, with process of melt buildup and drainage. When the amount reaches the critical threshold, which is equivalent to 7 volume%, the upper boundary of the melt connectivity threshold of Rosenthal inheritance. As the rock loses melt, it becomes progressively more residual in nature with decreased melt producing capacity with respect to its precursor. Coronan et al. 2013 tried to integrate about 36 volume% melt to the obtained residual bulk rock to, in a stepwise manner, down temperature to reconstruct the prograde metamorphic history of a UHT rock. It is possible that not all of the melt has to be lost until the metamorphic peak. Some melt may also be lost after the metamorphic peak. In that case, the metamorphic peak is not considered to be the least hydrated state of the rock. It is thermodynamically possible to quantify the amount of post-peak melt loss by using temperature melt fraction diagrams based on the work of Anderson et al. 2013. Now coming to the case study of refractory aluminous granulite, a saffron granulite from Anantagiri, which records peak metamorphic temperatures in excess of 1100 degrees Celsius, very high temperature. The possible reason is that this rock must have lost melt to a great extent while it evolved through its journey. And as a result, eventually this has a reduced melt producing capacity. On the contrary, this is another case study of aluminous metapelite, a normal garnet coriorite gneiss from Shillong, which records peak temperature of 850 degrees Celsius, which is much on the lower side. And the possible reason is that this rock must not have lost melt to that extent, and as a result the melt that was formed while the rock partially melted must have consumed substantial portion of the orogenic heat which buffered its temperature. So to conclude my talk, that partial melting initiates at the great triple junctions in the form of melt pockets. With increasing degree of partial melting, these melt pockets coalesce to form interconnected networks. The amount of melting needed to form such networks depend on the surface free energy of the dihedral angle. These networks, even if such networks are formed, the melt fraction keep on increasing until it reaches the MCT of Rosenberg and Handy. Tectonic stresses play a vital role in segregating and channelizing beds and the rocks. And finally, the rocks that are more refractory or residual in nature are that have undergone enough melt loss and has a reduced melt producing capacity are more prone to attain and preserve extreme thermal conditions as high as ultra high temperatures. Thank you.
Thank you. Any questions? So you mentioned about multiple melt loss events.
Yes, sir.
But how does it translate to deformation events? Do you think that there are multiple deformation events that drive out all these events, or because there is a model in recent times that actually melts do not go in pulses, rather it oozes out, continuously bleeds from the system. So that means you have to integrate the deformation events with the metamorphic events to understand the melt loss.
Yes, sir. Actually, this model, of Kolkata et al. 2013 hasn't incorporated the effect of deformation in this context. But obviously, deformation has a very critical role.
The second one is that I think this model comes from the same place you have mentioned, Anantagiri area, where the temperature is around 950, but you have calculated it around 1100.
Yeah.
So why is it different?
It may be because the rock that I have modeled may be a highly restitic or a residual rock that underwent.
The same rock. Model by Kolkata data is from the same rock. In Anantagiri you have only one exposure. You don't have many other exposures. Just you have to explore. This is my submission.
Thank you, sir.
Thank you. Thank you, Baruch.
The next speaker is Ajit Kumar Saha.
Good morning everyone. Myself Dr. post-doctoral research fellow from IISc going to present on the topic gaining an insight into the geological evolution of porcelain charnogite in the Eastern Ghat province and its implication for the correlation between India and East Antarctica. First, brief overview about Eastern Ghat belt. It is a northeast southwest trending mobile belt, ultra high temperature mobile belt. It is situated along the east coast of India and it is surrounded in the north by Sindhu Keton, and in the west by Bastar Keton, Harwar Keton. It documents evolutionary evidence of three river continents, namely Columbia, Rhodesia, and Gondwana, and it is intersected by several cluster-scale shear zones. Now come to the subdivision of Eastern Ghat Mobile Belt. Ramakrishna returned in 1998, subdivided Eastern Ghat Mobile Belt into 4 lithological domains. Accordingly, Western Condorite Zone, Eastern Condorite Zone marked by yellow color, and the Central Migmatite Zone in the middle, and Western Chalukite Zone. Later in 2001, Rickard settled put forward the concept of domain-based classification, where he suggested the Eastern Ghat is a club of several isotopic domains. Later in 2003, Dogme and Rai put forward the concept of domain and province-based classification, where he clubbed the Central Visawat domain, Northern Fulgoni domain, the Chilka Lake domain, Rampur domain, Tikarpara domain, and Angul domain within the Eastern Ghat province. This province dominated by mainly orthogneissic rocks, mainly Charnokite and granite. To cover this broad region, I have sampled from area location of the Eastern Ghat province. Here, the Charnokite rocks are crudely foliated, and their foliation is defined by Porphyro class of feldspar. And from the field elevation, they are magmatic in origin, and they truly include the metamsedimentary rocks of Eastern Ghats. That's why they contain enclaves of aluminous granulite and calcilicate granulite. Field evidence of metamorphism is also observed. As you can see, orthopyroxene plagioclase prismatic ridge layer is surrounded by garnet corona, so the plagioclase. Mafic granulite occurred in 2 different types. One is massive variety, another one is migmatitic, which show distinct melanosome and leucosome layer. But both these varieties occurred as enclaves or cooperatively within the post-Ghat Charnokite. Granite, on the other hand, is similar to field occurrence like Charnokite, and they are porphyritic also. And when they are highly deformed, they show they graded to felsic gneiss. Now come to the petrography. Based on mineralogy, 2 types of Charnokite have been identified. One is garnet bearing, another is garnet absent. Both have similar mineralogy, but both preserve the texture. Like orthopyroxene and ilmenite are surrounded by garnet corona. This type of corona texture can form by these 2 reactions. Again, porphyrotic garnet and orthopyroxenes show symplectite breakdown to biotite pores along the margin. These 3 reactions can occur during cooling from high temperature metamorphism. Again, few of the samples contain evidence of incipient melting, where biotite breakdown to ilmenite cables per symplectite by this reaction. This type of reaction can occur during heating, so it's indicating a deworking during granulite basis metamorphism. Granite, on the other hand, is also decrystallized, deformed, and preserves similar texture of garnet breakdown. Now come to the geochemical evolution of Charnokite. Charnokite show broad range from granitic to dolomitic variety, and they are metaluminous to paraluminous, and show broad range from calcic to calcalkalic, and they are similar to the Moshan coast and North Peninsula mountains of East Antarctica. On the other hand, trace elements show they show significantly art character, and they are evolved in a collisional tectonic setting. Whereas they show significant enrichment in rubidium, thorium, potassium, neodymium, zirconium, hafnium, and depletion in niobium, SR, TA, P, and TI. So LRE enriched and HRE depleted trained with negative europium anomaly. On the other hand, granite are paraluminous, ferro-1 to magnesian, and calcic to calcalkalic variety. They plotted in the overlapping tail of seen collisional to within plate granite, and they also show art character and enrichment in thorium, lead, neodymium, and lithium, and depletion from TA, SR, P, and TI. They show similar RE trend like Charnokite. Thermopyrometry here, the maximum temperature estimated using garnet orthopyroxene plagioclase thermometer after Pattison is around 19 degree 9.03 kilobar, while other thermometer estimate somewhat lower temperature. Now, to understand the pre-metamorphic history of these Charnokites, I do the forward modeling using perplex. But what could be a suitable protolith? Existing theory suggests that hydrated basalt radiation melting of amphibolite kaolin protolith could be a suitable one. That's why I chosen hydrated basaltic bulk composition from Eastern Dharwad Keton, and these are the constraints. These hypothetical fluid composition are taken for the study, and all the diagrams prepared in NCK mass system. 9 such diagrams have been prepared, and all these diagrams showing melting start above 850 degrees centigrade and 900 degrees centigrade and 1000 degrees centigrade 8 kilobar pressure. Melt composition have been taken, and they are plotted in a middlemost dash diagram to compare with our Charnokites. At 900 degrees centigrade, the resulted melt generate SiO2 percentage greater than 60% in type of granitic melt, and whereas at 1000 degrees centigrade the generated melt is 52-56% SiO2 content. And they does not match exactly with the Charnocite, but they follow the same trend. So theoretical modeling of hydritic basaltic bulk composition and CO2 fluidity would be a suitable prototype. From 8 samples, Japan has been separated and oscillatory domain are analyzed using LISMS here 2 phases of crystallization have been identified. One is between 1020 to 1000 mm, which is synchronous with the A1 metamorphism, that is UST metamorphism, and the most voluminous one is 980 to 940 mm, which followed the first cycle when the lower crust is recuperating from UST metamorphism. Similar time granitic magmatism is also reported by Bose et al. Japan trace element RD chemist also shows continental arc signature, and negative TI and eulobium anomaly is due to early fractionation of plagioclasm and PTI oxide. Obliteration of cerium anomaly, flattered LRE and concave up HRE suggests remobilization during metamorphic recrystallization. Now come to the tectonic model involving Eastern Ghat province and Renan province. Both these terrains have contemporaneous metamorphic and deformation history, but Eastern Ghat province suffered ultra-high temperature while the Renan province has suffered high temperature metamorphism, and the composite Renan Eastern Ghat province, which is now spatially different, are evolved into assembly of Catholic India and East Antarctica. But what binds them together is the Charnocite magmatism, which is known as Mosan Charnocite layer, and Eastern Ghat it is EGP Charnocite. Now this is the revised tectonic model from Mosan Charnocite area. 3 phases of emplacement history has been identified, which is missing. For the first phase has been missing from Eastern Ghat province, whereas phase 2 and phase 3 has been reported from Eastern Ghat province. The presently exposed REG now represent a cactonized arc system punctuated by Charnocite and granitic magma. Thank you.
Very nice talk. I have one question regarding one of the
pseudo sections that you have modeled.
Yes.
In some Charnocite.
Yes.
So, in the bulk composition, if I remember correctly, there was a CO2 value that you have given.
Yes.
So, can you just get me through how did you calculate the CO2?
This is a hypothetical bulk composition. I didn't calculate it. It is a hypothetical bulk composition. I just run it forward modeling to understand how in a CO2 rich province how the Charnocite magma has been generated.
Yeah. Thank you.
Thank you, sir.
Okay, thank you Arun for the nice presentation. Our next speaker is Subarna Boito from Aiza Berhampur. Subarna Boito. And she is going to give a talk on neodymium isotopic evolution of the Santur metavolcanic rocks, Central Harbour Craton, Southern India, and implications for enriched mantle source. So, Subarna, please try to restrict your talk to 8 minutes.
Good morning, everyone. I am Subarna Badia, and today I am going to give a brief talk on India isotopic evolution of the Santur metavolcanic rocks, Central Harbour Craton, Southern India, implications for enriched mantle source. So, before I talk about the case study area, I would like to give a brief introduction about the India isotopic evolution. So, among the commonly used radioactive isotopic systems in geological studies, SMNT is especially important because of several reasons. So, as it decays, the 147 samarium decays to produce 143 neodymium through alpha decay, and it is extremely important to date even ancient rocks because of its longer half-life of 147 samarium, and SM and ND both are rare earth elements which show similar characteristics and not show very much fractionation from each other, and ND is an immobile element. So it is very much resistant for alteration and metamorphism, which is a common phenomena in the Archean greenstone belts. And SM and ND both are compatible for minerals like pyroxenes, garnet, which are very common mineral in mafic and ultramafic rocks. So in geochronology, we use SM&D isotopic system, and it is a common equation which is used to determine the crystallization age for a particular system, whether it's a rock or a mineral. And other than that, we use for India isotopic evolution. So one of the reference system which we use for India isotopic evolution is the chondritic uniform reservoir, which represents the initial isotopic composition of our bulk silicate earth or the primitive mantle of our earth. So one of the first parameter which is going to be used broadly in this study is epsilon. This notation is used to compare between different reservoirs with respect to the chondritic uniform reservoir, and it is calculated using this following equation, and if the value comes positive, that means the mantle source is depleted, and if it comes negative, then it is an enriched mantle source or more fractionated mantle source. Then another second parameter which is going to be used in this study is f of SM&D, and it is basically calculated using this equation, and it also provides us information about various magma chamber processes and the evolution of mantle's composition. This is the study area. So on the left hand side, this is the broad geological map of the Dharwad crater, and it is now widely accepted that it is divided into three cratonic blocks, namely Western, Central and Eastern Dharwad crater. And our study area, the Sandur greenstone belt, is the only significant greenstone belt of the Central Dharwad crater. And you will get the information about the importance, how it is important in understanding the overall tectonomagmatic processes of the overall Dharwad crater in our paper by the et al. 2022. So samples were collected from all of the stratigraphic formation of this greenstone belt for whole rock major trace element geochemical studies, and among those samples, 15 least altered samples were selected for the whole rock SM&D isotopic study. So on the basis of their trace element analysis, on the RE plot, on the quadrant normalized RE plot, the LRT enrichment compared to the HRE, and on the primitive mantle normalized diagram, the LILE enrichment like rubidium, barium, thorium enrichment compared to the HRE, and the HFSC depletion like the niobium depletion compared to the HRE indicates towards the subduction derived magmatism for their formation. And also to be doubly sure, I have also plotted the average island art basalt, and average continental art basalt, and which exactly matches with the trend of these samples, static samples. So on the basis of the ND isotopic data, I have calculated epsilon ND and f of SM&D values. So there is the huge variation in their ND isotope epsilon ND values. So what could be the possible reason? So if their ND isotope ratio has been affected by the crustal contamination process, I have also included the plots of rubidium, thorium, zirconium on the with respect to 143 neodymium by 144 neodymium, and there is no discernible pattern with a large scatter in the data points, which suggests that their ND isotope ratio was mostly unaffected by the crustal contamination process. So on the left hand side, this is the useful diagram, as I have mentioned in the first slide, that epsilon ND is used to compare between different reservoirs. So with time, it is of our common knowledge that with time, the mantle source is going to be like with crustal extraction process, the mantle is going to be more and more depleted with respect to the Chur or chondritic uniform reservoir, which is the undifferentiated uniform reservoir. So as we move from Western Dharwad crater, which is the oldest, towards the Eastern Dharwad, we see there is a depletion. But in case of Sandur, the blue ones are the Sandur, which is part of the CDC, it shows mostly depletion, but some of the samples is showing enrichment in their epsilon ND value. So what could be that reason? So to understand that reason, I have used another plot from Shire and Hansen 1986, f of SM&D versus epsilon ND, and the plots can plot on any of these quadrants, but most of the plots are plotting on the fourth quadrant, which means these samples, the source rocks, were mostly undergone long-term depletion. That is why their epsilon ND is coming mostly positive, but they got enriched just prior to their partial melting. So that is why some of the samples we are getting epsilon ND negative error as well as F of SMND is mostly negative. That means LRE enrichment is there. So they were depleted for a longer period of time, but just prior to the melting, some of them got the enrichment. That is why we see this kind of anomalous value. So there is a heterogeneity in the mantle source. In case of Sandur, we can see. So this is the subduction model proposed by Jayanande et al. 2013, where you can see the WDC acted as a foreland for CDC subduction and CDC acted for a foreland for DDC subduction. And on the basis of the lithological assemblages of the CDC greenstone belt and their mantle source characteristic, you will get in Vaidya et al. 2022 paper. And here as well we have seen that on the basis of ND isotope ratio and epsilon ND values also, this CDC is showing some heterogeneous kind of nature. So as we move from WDC towards CDC, we see a transition zone in between. And keeping in mind about the narrower width of the CDC, we can say that it is a mobile belt rather than a cratonic block. So thank you everyone.
A quick question.
Consider it as a mobile belt now. So actually it is not a very widely accepted idea that there are three different crustal blocks and tectonic blocks. There are models where community they are twofold.
Yes,
models and in between there is a transition zone by channel.
Yes. No, the recent literature is mostly considered.
It started from Jayananda et al.
Yes, yes.
Onwards there have been
Buchanan
jump into that, but I would request you not to be influenced by that kind of. I mean, you also considered the older accepted classification, and as you are also establishing it as a mobile brain kind of thing, then they are also not a crustal block which is coming out. I just wanted to know, where did you do your analysis?
The analysis I have done, like the result I have got from external laboratory.
Thank you.
So the next speaker.
Goal of geochemical and NDSR isotopic studies of the granuloids from the eastern Aravalli terrain, central Aravalli Plateau, northwest India. Introduction. The Hindoli Jahajpur granuloids are located in the eastern Aravalli terrain of Rajasthan in India, and the eastern Aravalli terrain composed of various rock types such as metamorphic granitoids and gneissic rocks. The basement of these granitoids are considered as the banded gneissic complex. This is my studies area. Mostly I have collected in this region is considered as the eastern Aravalli terrain, and this map given GSI map Gupta et al. 1997. Methodology. Field visit and investigation and petrography using a petrological microscope. During the petrological microscope, I have found quartz, calicoclase, K-feldspar, biotite, and etc. And major rock site samples are analyzed by XRF, and trace element done by HR ICP-MS, inductive plasma mass spectrometer, high resolution mass spectrometer. Result and discussion. In these
given by Shine 1994. The most of the samples are metaluminous, and there are three samples are paraluminous in nature. The metaluminous are mostly found in subduction zone environment, less to the partial melting of mantle wedge and interaction with the overlying crust. The albite, anorthite and orthoclase diagram also show these granitoids are floated in the granitic bed, and these figure given by the O'Connor in 1965. In the FM diagram are plotted in the calcaline trend. They are supported to the magnesian nature. These are magnesian nature because of the subducting plates are hydrous, and they are supported to the partial melting of the subducting slab. Chondrite normalized rare earth element pattern after McDonough and Son. These diagram are so light rare earth element enriched as compared to heavy rare earth element, and also show the europium negative anomaly, which suggests that the fractionation of paleogeolite in the source. And multi-element diagram also suggests that the negative anomaly of niobium, titanium and strontium. These are also helpful for suggesting that these granitoids are generated from the upper continental crust. Conclusion: the Anthology granite are metaluminous and alkali-calcic in nature, as well as magnesium nature. These indicate the partial melting of the upper continental crust. And EFM diagram also show the calcaline trend, and also show the negative relationships between SiO2 and P2O5 correlation. They are suggestion to I-type granitoids, and the rare earth mineral pattern showing the paleogeolite fractionation away from the source. That is why we are getting negative europium anomaly and garnet free source, because we are getting the negative slab. And initial strontium 87 and strontium 86 ratio, and negative epsilon Nd 2.5 giga-nm, value minus 5.67 to minus 1.7 to suggest the derivation from the continental crust in a subduction zone environment. Thank you.
One or two quick questions.
Thank you for your talk. There are different phases of granitic activities within that belt. So which granitoids have you chosen for this presentation? Are they the basement granitoids, the Mangalavarnesis, or the intrusives one of 2 or 3 generations within the suprapersoil belt?
The emplacement granite are chosen, which get 2.5 giga-nm.
आपके जहाजपुर ग्रेनाइट जो है उसको डेट की उसको स्टडी किया है?
जी
जहाजपुर ग्रेनाइट
जी सर.
These data models, they are available anywhere.
I was curious to know from you that in a subduction zone environment, normally melts are derived from either the mantle or the hydrated crust. How can it be from the continental crust in a subduction zone, melting of continental crust?
The subduction slabs are moving down. The hydrous minerals are reduced and lower the partial melting of the upper continental crust.
Go back to your rare earth elements plot. Yeah, here not all has the similar features, because your two samples, they are positive and nuclear.
of physical process of changing in a subject. It's very difficult to get a continental crust from the scientist.
Yes.
And your features in the what you are showing in the alkaline thing, that is not actually it's not, it's just an assembly of data, some plots. It's not showing a alkaline thing from A side to A side to B.
Yeah.
Okay. Okay.
Thank you.
Hello, I'm Payal, post-doctoral research student in ISAR Behrampur, and today the topic of my presentation is the minimal olivine crystallization in Paleolithic basalt explained by binary compositional diagrams. Now, if we talk about the continental flat basalt provinces, many of them contains, including our Deccan volcanic province, contain predominant amount of olivine, giving rise to picrobasalt or picrites. Here I have listed few examples, but many of them have very remarkably low amount of olivine. And here in this presentation, I will try to present how the minimal presence of olivine can be explained by the help of data from a very recent cooling experiment and using few bivariate diagrams, variation diagrams. And for this, we have used a basalt sample from Khandwa, Nimar district of Madhya Pradesh, belonging to the Eastern Deccan volcanic province. And if we talk about this area, there are 3 different lava flows identified on the basis of 3-tier classification. And here I have listed a few field photographs from different structural zones of the lava flows based on which the flows were identified. And if we talk about the petrographic study, different textures like bromoporphyritic texture, ophitic, subophitic texture, granular, interstratal, intergranular textures are common in this rock. But during the petrographic study, olivine was not found, but the mineral chemical study showed that in the BSc images we found that few olivine grains are present in the thin sections. Now, if we talk about a brief summary of the experiments I have just mentioned by More and Shear 2019, they have used a kilobea basalt sample, tholistic basalt sample. They have melted the sample by at 1290 degrees centigrade and then rapidly cooled the system into different temperatures so that olivine can crystallize. Their aim was to study the growth rate of olivine and different properties of the olivine grains. We have used their output data, what they have obtained after the olivine grains were crystallized in different proportions. We have used that data in our exercise. Now, our intention was to find out the nearest possible experimentally obtained composition, the glass composition, and we have we have plotted our olivine EPMA data in these variation diagrams, these 5 variation diagrams, along with the glass compositions experimentally obtained. And we have tried to deduce the parent composition of our Khandwa olivines depending on the lever rule. Now, if we talk about the lever rule, for a crystallizing magma, whenever a crystallizing phase appears, the parent magma composition starts to change towards the residual liquid. And percentage of fractional crystallization and percentage of remaining liquid can be calculated with these formulas. Using these formulas, we have drawn these variation diagrams. In both of these variation diagrams, the green circles represent the EPMA data or the olivine compositional data, and the blue, yellow and red symbols represents those glass data data which we have taken from the experimental study of lowland shear. And here the A represents the average compositional data of olivine and B represents the nearest experimentally experimentally obtained data. And the percentage of crystallization were known. The different symbols here, blue, yellow and red, they represent different proportions of olivine fractionation. And from these informations, we have calculated the position of P and calculated the different major element oxide compositions of the parent. And here the SiO2, major element SiO2 and Al2O3 both are more in the parent melt than in the olivine of Khandwa. And the parent melt composition is almost similar to the residual melt, the daughter melt. The glass compositions here we have considered as daughter melt, and they are almost similar, which indicates that very less amount of olivine has crystallized from the parent melt. And here also the same exercise we have done, and the P2O5 is much more in the parent melt than the olivine. The same exercise has been done from this diagram. Here we have compiled the composition, major element composition of the parent, and depending on that we have calculated the CIPW norm. And from the norm it is indicating that the parent melt is a quartz normative toluene type of basalt. For conclusion, we can say that the olivine fractionation from the parent melt, a very minimal amount of olivine has fractionated, approximately 2 to 4%, and when the parent melt ascend during the journey of the parent melt upwards, when it traveled a thick lithospheric depth, it became quartz toluene, and the minimum amount of olivine became decadent. And spectrographically that is also evident from the relict or decaying olivine present in our samples. And the Al, Si and P, these elements acted as an incompatible element into the olivine structure, and this is a petrogenetic model we have tried to form, which can be extended to other continental flat basalt provinces as well. So these are few selected references I have used in the that publication. And
conference বাইরে
You have all experienced in the dry conditions or wet conditions?
The parent, what they have used, I mean
it is a natural sample.
It is a natural sample from Kilauea. It is a dry vessel.
It is a dry vessel.
Fully empty vessel.
But in a resort, you should have some amount of water. Isn't it? There is some water. How do you constrain that?
Sir, actually we have taken the data from the experiment they have done. They have achieved, I mean, after the olivine separation, the glass composition that is left, we have used that data for our daughter.
Any other gas control you have maintained? That is a rod in a one atmosphere, making 1 atmosphere situation.
Actually, it is not our data. We took it from other experiments.
These are your natural samples. You have done in your laboratory, no?
No, sir. The experiment was not done in our laboratory.
No, you have an experimental laboratory. Okay, thank you.
Please. Did I understand you correctly? Correct me if I am wrong. That your olivine data in the diagram was from your samples.
Yes, the olivine samples were from Khandwa.
These are from your samples.
Yes.
So the red data are from the experiments. So don't you think that there is some inconsistency in that? That you are getting this olivine?
Sir, actually they have
from one crop and then merit from
another crop. Yes. Sir, actually Actually, they have used a polyolithic basalt from which olivine has separated. So, for
I'm not contesting what
actually, it is a model cell. We have tried.
Would you find some lead fraction in your samples?
In my sample, glass were present.
So why didn't you determine any contribution of glass or secondary to the olivine?
We have, I have the glass data also, EPMA data of glass. From that, I could have
that with your olivine. That would be more meaningful than combining this.
And also now people are doing glass inclusions, made inclusion analysis.
Olivine in liquid is very important for your experimental studies. In a liquidous phase, olivine phase, developing in a liquidous phase.
You can discuss while you discuss.
Very exciting.
From the Neogen sediments was mainly because of the high sediment input from the Himalayas to the north, in the Myanmar ranges to the east, the Karbi Anglong Massif to the west. So there was high sediment input because there was an increased precipitation and weathering during the sedimentation of the Neogen sediments because of the rapid uplift of the Himalayas. So monsoon had started during the Eocene, but because of the Himalayas reaching such a high altitude by the Miocene, the monsoons were intensified within the Indian subcontinent. So because of the intensification of monsoons, there was more sediment input into the belt basin than the Miocene climatic optimum. So there have been studies of these rocks which have been linked with the Miocene climatic optimum. So because of all this, there was a high sediment input within the basin, and also okay, this is the last. So the size mites that were shown were because of the active tectonism that was occurring within the basin because of the partition of the Indian and Burmese plate. So these are references that I have followed, and thank you all. Thank you for your I'm ready to take sediment loading because of high sediment input, but a lot of these soft sedimentary formation structures had a large lateral extension, like I discussed earlier. They could be traced from the river valley up to the top of the hill, and it also extended across like several tens of meters across the mountains.
I think there is quite a lot of work need to be done because many of the features do resemble vegetation. Anyway, and number two is why do you relate this with climate? What climate has to do?
Because
even if the monsoon is there, what is the age of the rocks that you have looked into, where you have seen it?
These rocks are Neogen age.
Neogen is a very big bracket, but it's more specific.
I think it's Miocene.
Yes, it's Miocene.
It's Miocene.
Yeah. So the sedimentation of these rocks coincides with the Miocene climatic optimum, which was phase of.
Yeah, how it is related to the climate? I don't get it.
Because when there is more, when the climate is warm or humid, there is more disintegration of the rocks. There will be more weathering. There will be more erosion. There will be more sediments to be deposited in the basin.
That doesn't induce soft soil uniformity.
So,
I don't think this is related. I mean, you must be very modern, but it's probably not related. Climate is uniform over a few billion years, and these beds are instability. They will take up for a long time. So there must be some other precipitating factor. Anyway, it's part of your.
During this time, during the Miocene only, the Indo-Myanmar hills were being uplifted, and to the east and towards the west, the Karbi Anglong hills were being uplifted. So when these rocks were being deposited, significance of these deposits is there was increased sediment input from these two sources. Before this, there was more sedimentation from the Himalayas from the north.
Madam, okay. I think what sir is trying to tell you, the dynamics of PCBs, that has to be understood in vis-a-vis the climatic optimum on PCBs.
Yes.
So, because this type of structures is formed, it has a particular dynamic in it. Otherwise, it will not be formed.
Yes.
So that you have enough material to do further research.
Yes.
Do it. We are very pleased to see a lot of unique structures here.
Thank you.
So, best wishes for your
thank you.
research.
Thank you.
I'm not on to finish school. The thing is, all these things are in Jammu.
Yes.
In which sir?
In the highway section as well as other sections which are accessible from other links.
Other link.
Yes.
That means you are going to the new land or something like that?
Yes, towards Newland also, towards
Okay. But another thing that I want to say.
and all the small link roads in between those main roads.
You tried to talk about this sedimentary structures with a collision.
Yes.
The collision took place in Oligocene.
Yes, sir, but it was continuing.
Yeah.
It's still continuing.
It's still going.
Yes.
But you don't see earthquake right now in Nagaland.
No, I think if we can look into the data of the...
If you go to the seismic
Yes,
records,
yes.
you don't have earthquake in Nagaland. Unfortunately, we are not very happy with that as far as the science is concerned. But
there has been earthquakes.
So now it has stopped.
No, it's still the condition or
No, earthquake.
Earthquakes, it's not going to happen all the time. But
Yeah.
of course, we do feel seismic shocks once in a while.
But Girijan clay, do you find in Chumupi? No.
Yes, it's there. It's there.
In Chumupi, no?
Yeah.
Really?
Yes, sir.
Do you find in Chumupi or Girijan clay?
I don't remember. Girijan clay is there in the center of that also.
And Girijan clay you will find after Tibang, right? But I don't know whether you were.
Okay, so it's there on the highway stretch as well, and like towards the, I think east of the river bank also, like towards Laswani and all, you can find these major things.
Okay, thank you very much.
My presentation is Pebble conglomerate deposit from Lesser Himalayan Proterozoic succession, Himachal Pradesh, India. The depositional and stratigraphic implication. So at first let's see the location of my study area. Here in the map, the blue colored area is my study area, which is situated at the hanging wall block of Giri Thrust just north of MBD. And this area is mainly consists of Johnson group of rocks, which is our main focus of study. The depositional setting of Johnson group is yet to be established because lots of opinion exists regarding the lithostratigraphy of Johnson group, and this is because mainly of the lithological monotony. Major part of Johnson group is consists of sandstone and shale, so it's very difficult to correlate individual units. But surprisingly, we have found a very prominent Pebble conglomerate unit within the succession, which is already mentioned in Auden 1934. This is the field photograph of the Pebble conglomerate unit, and the close view of the unit is in the insect. The unique characteristic of this Pebble conglomerate unit makes it distinguishable from any other unit of the lithosuccession. We have done detailed facies analysis of that unit. This unit is characterized by its lateral facies variation. So from proximal part to distal part, we have got almost 8 different types of facies. The first one is wedge-shaped massive Pebble conglomerate, which indicates a plastic type of debris flow deposit. The next one is Pebble conglomerate, with preferred clast alignment. This type of phases indicates that the deposition took place under dominant tractive flow condition. The next phase is tabular massive peptic conglomerate, which is the indication of a hyperconcentrated seed flow deposit. Next, the fourth phase is normally graded granular conglomerate. This type of phase is very common in turbidite deposit. The next one is pebbly conglomerate with core-scale inverse grading. This is also a common phase found in turbidite deposits. The sixth is bipartite tabular conglomerate. Here in this image, there are two bipartite units situated successively. In each of the units, the fossal material is segregated in the lower part, whereas the final materials are segregated in the top. And this is also commonly found in turbidite deposits. The seventh phase is cover-filling cross-fitted granular sandstone. This is the distal part. This phase indicates a unidirectional stream flow type of deposit. And the last one is medium grained sandstone with asymmetric ripples. Though the ripples are asymmetric, but the very low ripple index, due to the very low ripple index, we can consider these ripples as symmetric or wave ripples. That indicates the deposition took place above the normal wave base condition. So, the detailed phases analysis can be summarized as the proximal part of the unit has deposited under a debris flow condition. Then the debris flow was transformed into a hyperconcentrated flow deposit. Then this hyperconcentrated flow has transformed into turbidite flow. And at the terminal phase, the turbidite flow transformed into a more dilute stream flow deposit. So overall, we can say that this huge pebbly conglomerate unit is a high density mass flow deposit. Next, coming to the another important point, the extension of the unit. This is the Google Earth image of my study area where I have marked 4 locations in Europe, and in each location we have got this prominent pebbly conglomerate unit exposure, and the distance between the two farthest locations from Waknakhar to Tons is almost 80 to 90 kilometers. So we can say that this is a regional scale or basin scale unit. Then we have determined the age of the conglomerate unit using the detrital zircon uranium lead dating technique, and we got the maximum depositional age of this unit less than 634 million years. There are some important points regarding the associated lithosuccession which lie below the pebbly conglomerate and above the pebbly conglomerate. When we see the lower succession below the pebbly conglomerate unit, we are getting this type of thick succession composed of alternating sand and silt, where we have found some important sedimentary structures like lode cast, flute cast and convolute bedding. All of these features indicate the succession as a deep sea succession, deep sea sand type of succession. And when we see the lithosuccession lying above the pebbly conglomerate unit, we found this type of structures like columnar stromatolite, wave ripple and syneresis cracks. All of these features indicate a shallow water feature. So, across this pebbly conglomerate unit, the depositional setting of the basin has changed from deep sea to shallow sea. So, we can conclude from the present study that the pebbly conglomerate unit of Johnson Group is a basin scale high density flow deposit which can be used as a marker bed for lithostratigraphic correlation. This type of huge conglomerate deposit can occur only by some major tectonic event. Further, across this pebbly conglomerate unit, the depositional setting of the basin has been changed, which possibly indicate a force regression. And this Johnson group of rocks is overlain by Kroll succession, which was established as a prototype of cryogenian snowball arch succession. And now it is established that this cryogenian snowball arch succession was the consequence of Rodinia supercontinent breakup. So we may relate this huge prominent pebbly conglomerate deposit with the supercontinent breakup event. This is my references. Thank you.
Question. So you have mentioned that the detritus are to determine the age of the particular succession. So that's a sedimentary succession, right? So detritus zircon is coming from either any igneous provinces or any metamorphic provinces. So how that zircon can be used to determine the age of that sedimentary succession?
I have
deposition is.
Here mentioned that the maximum depositional age of this unit is less than 630. That means we have.
100 million years also.
But this as the Johnson group of rocks is overlain by Kroll succession, and we know the age of Kroll succession. It is also Neoproterozoic around 550 or 600 million year. Exactly.
How was that?
This was also determined by zircon uranium rate dating technique.
So same question arises there. Same question.
But
there is some constant, but you should not give much importance to it. Unless you have a different constant. Can you show in the basis table? There is one slide in which you showed that
different flows or components.
The points.
No.
Yes.
Yeah.
Yes. You write on, see the dart, this in turn transform into target. And then you write on further dilution, the cardinal phase is again is stream character of cardinal.
Stream flow means the sediment population is getting more diluted. The concentration of the grains
under sea or on the surface of the stream is on the surface of the or stream
under sea.
Should not be mentioned. The transformation may take place. One more question, the proximal part you said is what is the percentage of matrix?
I'm not estimated, just from field observation.
And you have shown one massive pebbly component in which class do not have a space. We call that as a hypermorphic. Why that is?
Because this photograph I think is the
tabular one. Yes.
This one.
Yes.
This is from this field photograph we cannot see the base geometry of the unit, but the base geometry of the unit is tabular. The contacts are sharp. So from the base geometry we can say that it is a.
It can be a debris source. Any mass flow deposit is likely to have a so don't use this photograph for last
rocks and the Johnson group of rocks are equivalent. Now you are saying that Johnsons are found in Wagner, but I think the ones in Wagner come under Shimla group.
These terms are confusing. The Johnson group, the Shimla group. So from literature survey, we came to know that the western part is known as Johnson group.
Yes.
The western part is known as Shimla group. The area around Shimla region, the Wagner, Kandaghat, this type of area. But in the eastern part, the area in Uttarakhand around Tons River, this is known as Johnson. We have used only one term for this formation.
So it's Johnson group. So getting conglomerates, which formation are you working on? Like what is this about? Which formation is it about? From which formation?
Sorry. I mean, we have a shortage of time, so you can discuss later.
So one last question. See, your detrital zircons is showing 634 million years, which is cryogenian in age. Now, Shimla and Johnsons are known to be Tonian in age, which is 1,000 to 720 million years. So I think you need to revisit your interpretation and your references.
I think you should stop with that.
Yeah. Okay. Thank you, sir.
Good afternoon everyone, my name is Ajit Saha. I am doing PhD in the Department of Geology of Presidency University under the supervision of Dr. Prof. Now I am going to present the presentation on the topic of past susceptibility and mapping in Russellpur River Basin, northeastern India using remote sensing GIS and analytical hierarchy process techniques. So these are some sub-points which I am going to discuss right now. In introduction part, I would like to say that according to UNC in 1992, more than half of the world population currently living within 60 km from the coastline. But in recent decades, floods have been one of the most common natural destructive disasters, causing massive damages to natural and human resources, especially in coastal areas. Therefore, this study attempts to delineate the flood susceptibility zone in the Russellpur River Basin by using remote sensing and GIS techniques. So these are some pictures of the study area this year. So our study area basically coastal province of Purva Medinipur district, which is situated in northeastern India. The study area composed of unconsolidated quaternary sediments consisting of sand, seals and yellow to brown clay. In our study area, normally hot and humid type of climates are found, and maximum amount of rainfall occur between June and September months due to southwest monsoon. Some material and methods to delineate the flood susceptibility zones. We have used analytical hierarchy process technique along with weighted overlay analysis method. For that, we have collected different types of data from various sites, like geomorphological map was collected from Geological Survey of India site, the lithological map was collected from Department of Industry, Commerce and Enterprises, Government of West Bengal 2022. Soil map was collected from National Bureau of Soil Survey, Land Use and Planning, and rainfall data are collected from Central Groundwater Board report. The thematic layers like elevation, topographic coordinates index, topographic roughness index, stream flood index, sediment transport index, distance from river, DNS density, curvature and slope were acquired from Alas Pulsar dam data. Land use land topography map were prepared from Landsat 8 images, and ArcGIS software was used for preparing all the thematic maps and to delineate the class accessibility zone. So we have prepared 50 thematic maps, and every map was georeferenced and projected over the datum of WGS 1984 and UTM zone 45 norm for easy handling AS environment. So this is the earth map, which is elevation map of the study area. Second one is slope map, then dynamic landform map, geomorphological map, lithological map, rainfall map, normalized difference vegetation index map, drainage density map, distance from river map, soil map, topographic wetness index map, topographic roughness index map, stream flow index map, sediment transport index map, and temperature map. Finally, we have used analytical hierarchy process technique, and we have the weight to each parameter on the basis of literature review and expert opinion. After that, to give the rank to each classes within each parameter, we on the basis of relative importance of class susceptibility. And weighted or multiplying by that to get the total weightage. And finally, on the basis of total weightage, we have used weighted overlay analysis method, and the class susceptibility map of Presidency University basin has been produced. Now the validation part, according to previous researchers, Sentinel-1 data, Sentinel-1 SR data is particularly suitable for large-scale inundation mapping and which can be used for flood analysis. To detect the flooded area in the Dashalpur River basin, a series of Sentinel-1 before, during and after flood were collected from Sentinel-1 data. And this one was the before flood image of this year, and this is the after flood image condition of this year. To validate the flood susceptibility map, we compared it to flood inundation map, which I gained from Sentinel-1 data in Google in this platform. The result of validation reveals that 74.46% of the flooded area comes under the very high and high flood susceptibility classification. So, this is the northwestern part of our study area, which is very high vulnerable to flood. And if we see that this in this part, mainly two type of geomorphological unit. One is older surface and one is older elevation and is dominant. And in this part also agricultural field also dominant. And this is a land proper unit. So to know the reason why these units are influencing on flood, we found that the older elevations in this area has flat slope towards the sea. The polytent mantle occurring on level to nearly level shoreline alluvial plain are vulnerable to severe families. According to previous research, increased sedimentation in an area of a river basin exacerbates the flood of that area. In the study area, a large amount of sedimentation occurring due to subidal activity, by subidal activity due to river progression. In the agricultural fields in this area are classified as medium to lowland that induce water leaking due to heavy rainfall and poor drainage. So, in the conclusion part, it is concluded that geomorphologically older alluvial plain and older terrain is vulnerable to flood, and furthermore, this study also reveals that agricultural land is highly susceptible for flood in studio coastal landscape. So, the outcome thus to establish that GIS and AP techniques are suitable to identify and map the flood susceptibility zones, and can be used more effectively to mitigate the serious impacts of tapping in the coastal alluvial region. So these are some references which I have used for this study. And thank you.
Are you doing PhD?
Yes.
What I understand that there are different very good flood risk models are available. You should use all those things. Number one, you should not stick to up to susceptibility. Since you are doing PhD, that's why I am asking. You take this part at the higher level where you can have a risk map, flood risk map developed. That means in the risk map you have to take into account 2-3 things additional for which you have to go and generate more data. That is, one is the vulnerability. You know what is vulnerability? Vulnerability is the extent of damage. So for that you have to collect damage information of the earlier flood. Okay, and that damage you have to plot, and it will generally follow some distribution curve, and from that you have to have your vulnerability. Then element at risk. Nowadays in remote sensing, you know, building footprint map and these things can be calculated very easily. So those things you take into your these things, and then you develop just part susceptibility map which is not serve the purpose. You should have a flood risk. Okay.
One question was, in your title you say the mapping of visible river basin northeastern India. Do you know what is the northeastern part of India? What are the states there?
Yes, sir. I have seen and in some papers like in the Purvameni district is considered as northeastern India.
Has anybody asked? Purvameni is a northeast India.
All the seven sister states, Assam, Nagaland, Manipur, this stuff.
This is also eastern. Don't use northeastern. Okay.
Next.
Good afternoon everyone. This is a research scholar from Department of Geology at University of Kolkata. This is the presentation topic is study of artificial and subsurface distribution of Mars foraminifera from the plains of Matla rivers in North India. This is the talk outline. Introduction. First, the introduction is Sundarbans area. Sundarbans area is the largest mangrove wetland, and it is situated in the southern parts of the West Bengal, and it is the 40% coverage of the mangroves in that area. Here, the many tributaries and distributaries rivers in that area, and mainly of the Ganga, including the Muriganga, Saptamukhi, Thakuran, Namla, and Vidarbhani rivers, among others. And my research topic focuses on foraminifera. Foraminifera is the unicellular eukaryotic protist, which excellent indicators of the climatic changes in recent. And this is the basic information. Foraminifera are often encountered in surface sediment and core samples taken in that area. Total 28 surface samples and 1 short core collected from the banks of the Matla river and from Deulbai to Achintanagar.
How deep was the short core?
Short core for benthic forum deposited in there. That.
And how deep they?
Oh, 20 centimeters.
Okay.
Next. This is the main topics. Firstly, to examine the foraminifera populations, both living and dead, in the surface marshes along the banks of Matla river, and then investigate to the living community of foraminifera and their cell composition variations, both at the surface and down the core, which will aid to identify the microhabitat of these benthic organisms. And this is the map showing L1 to L28, and here the core samples are taken here, that is C1. Methodology. And these the core samples and surface samples taken, and these core samples interval sliced at 1 cm intervals and processed for the investigation of bending foraminifera, and surface samples in the field rose Bengal stained with rose Bengal solution to distinguish between the living foraminifera and dead foraminifera. And this is the total 14 species are identified. Here are 5 species. A, B is the Ammonia becari, and C, D is the Ammonia tepida, E, F is the Ammonia parkinsonia, and G for the Kolkata matensis, H for Typhoephedrium quena. And this is the spiral view and umbilical view. And here is the 9 species are identified, which are Calcareous, hyaline, and antituberate based in there. And A for Typhoephedrium spitulum, B for Helphidium actinum, Hydraceae diffusula, Hydraceae germanica, Quinopelina, Seminulum, Procamia insecta, Haplotyphanes caenesis, Haplotyphanes sulfati, Minimina fusca. And this is the only side view. This is the Minimina fusca side view. And E is the agglutinated forms. Several statistical analysis done. Here the total foraminifera number of per gram of dry sediments and these sampling locations, and L1 to L28 in soil. Variation of total foraminifera number along the sampling locations. And it is the living foraminifera statistical analysis L1 to L28. And this percentage of wall test types, porcelaneous, hyaline, and agglutinated, and maximum plotted in hyaline section. This ternary diagram is called Morris ternary diagram. And this percentage of populations can be drawn in Fisher's alpha index, showing the diversity of foraminiferal assemblages, number of species, and number of individuals, and shown alpha value 1 to 3. And core sample statistical analysis, here the C1 to C20, 1 centimeter intervals are taken, and this majority of samples in that area, and this is condition of ambient environment conditions in there. And each forum species are identified in core section, and Hydraceae, it is the Hydraceae diffusula, then Typhoephedrium spitula, then Helphidium crispum, Ammonia tepida, and Ammonia parkinsoniana, Ammonia becari, Hydraceae germanica. All that species maximum abundance in C6 to C9 and C18 to C20. And these 4 samples test percentage, they are calculated and the percentage plotted in these hyaline sections. Discussions. In further samples study, Ammonia tepida and Ammonia becari are the dominant and abundant species which can seen at G3 forest, which is L3. The highest number of species has been found, and total foraminifera number varies 0 to 708 per gram of dry sediments. And core sample studies Hydraceae diffusula, and actually this is the locally schools of species, abundant species in that area is highest, and maximum abundance 8 cm and 18 cm, that indicates the high level of oxygen and nutrient supply availability in that area. Concluded that living foraminifera make up of the 50% of the assemblages at certain sampling stations. Morris ternary diagram shows the samples have a dominance calcareous hyaline forms in this region, and diversity overall assembly is low for Fisher's alpha index. And core sample statistical analysis most comprises of calcareous hyaline test, the presence of Hydraceae species Ammonia tepida suggesting the fluvial influence and higher clay percentage in the area, and biodiversity helps the transporting the living forum in the core, in the deeper level of sediments. And that is the selected references. and I acknowledge to my lecturers. Any question?
I have just a general question like, is there any variation from upper Matla and lower Matla in the species variation or any?
Further studies have differentiated upper Matla and lower.
You have talked about climate. Does it have any bearing on whatever you have to form?
Climate, there's some recent sediments. Here the changes of the rivers conditions. So it can be implied that.
You have mentioned the influence of river dams. Quite understand. Is that right?
More work in this topic.
The solutions are mostly deep but not. This is the pole that have the myelonite relation, and some are in the southern dipping also. And there are several faults. Also look into it. In the field data, we mostly found F1 recumbent faults, which are mainly recumbent and isoclinal in nature. When F1 folding is coaxial and forming F2 folds, and which is for F3 interference pattern, which is hooks and pattern. These are the three figures from the field. The F3 recumbent are from the mainly open type of recumbent folds, which are also the coaxial to F1 and F2, and F4 are the cross to the F2 folds, F2 fold axis, and forms open and dome basins, dome and basin structures. Also in the study area, mineral lineations are also found. Here we found the mineral lineations and myelonites. This is the quartite rocks which shows the mineral lineations, so the stretching lineations in quartz grains. And also the silken lines are formed here. This is the mineral lineations in a quartzite rocks, and this is the silken lines which showing down the directions. The microscopic study of the quartzite sample shows the SC fabric, mainly shows the textural movement of the SC, and the S0 eastern plane, which is mostly found in the condylite rock samples, mainly sillimanite garnets, and the quartzofeldspathite layers are there. So from that data, we mainly calculate the vorticity analysis, and vorticity analysis can be done by finding the vorticity kinematic number, and it is measured in the vorticity profile plane, which is the parallel to the lineations and perpendicular to the collision plane of the rock sample. Then we measure the kinematic vorticity kinematic numbers by RS by theta method. RS is the aspect ratio of the quartz grains, which is recrystallized and formed in the AS fabrics, and theta is the angle between AS plane and the C plane. So this I have taken these samples, which is mostly formed in the transcriptional zone in that area, and this data is transferred to the pure search simple search conversion chart, which is mostly found. This is in the simple search region. So this is the wall diagram, which shows the tectonic history of the study area. We can say this is the sedimentation in the eastern Ghat portion, which is deformation. When D1 deformation, the F1 folding is formed in the recumbent, and the coaxially F3 interference pattern is formed due to the F2 folding, and D3 deformation is formed due to gravity induced and formed open and recumbent fold, along the limb of the F2 fold. F4 fold is formed during the deformation D4, which is close to the F2 fold axis. After that, the shearing of Mahanadi shear zone, which is also called as Paipan Mahanadi Dhodi shear zone, which is a great lineament along that region, is formed due to due to that time, which is also in that time also exhumation of Eastern Ghat mobile belt is occurred. Parallel to the shear zone, the fast normal fault is formed, which is mostly deposits the Gondwana sediments in that region, and after that D7 deformation is the conjugate shear fractures which formed in that area. So we can say there is D1 to D7 deformations from ductile to brittle. So here we can say that apart from the Mahanadi shear zone, we have also several shear zones like Riyamar shear zone, Parakot shear zone, Kerazan shear zone, Anupur shear zone also. All are textural in nature, and from the textural nature, mainly Gondwana basins are formed between the shear zones, which mostly deposits the Gondwana sediments and the coal rest in that region. So D1 to my conclusion statements are that D1 to D4 deformations are mostly holding. D5 is the textural shear zone, and D6 and D7s are mostly associated with faults. Due to the transnational deformation, which is finding in my result, we can say that of that transnational deformation, myelonites are developed, and from that myelonites and strike slip faults are formed, so that the normal faulting is happened, and Gondwana deposits are also leading to that, and Mahanadi rifts are formed. The transnational setting probably gave to the Mahanadi rift, along which of the Gondwana deposits. These are my references, and thank you.
Any questions?
Yes. On the right hand side of the photograph.
Can you keep the pointer?
Yes, sir.
Is this a plane perpendicular to the face of the?
Sir, yes, sir. This is the foliation plane only.
So that is the foliation plane.
Yes, sir.
Then this is not this stretching. This is simply an intersection line. This is not your stretching relation.
Sir, I will see.
That's not a foliation plane. You have to see this stretching
Sir, this surface is the foliation surface.
What is this surface? This surface.
Sir, this is the
Yes.
No, it is horizontal. What is that surface? Is that any?
No, sir. Horizontal surface is not the foliation surface. The vertical section that we are seeing, this is the foliation surface.
There is just some horizontal put in place or something.
Okay. And the very last time, where you discuss your
This one.
After this. Yes. This is your model of the two-part basin.
Yes, sir.
So in this model of the two-part basin, the two-part basin forms only in this monopole. The basin forms only when the two faults overlap. So the top fault extends towards the right and left,
yes,
and ends towards the right.
Yes,
And the bottom fault ends towards the left and extends to the right.
Yes, sir.
Okay. But in this diagram, both the faults are extending beyond the basin. So this cannot be a polar part basin.
Yes, sir. I will
Do you follow my argument?
Yes, sir. Yes, sir. Yes.
So why do you interpret that as a polar part basin between these two faults? These are not overlapping faults. They are simply two parallel faults?
That is saying that as they are in dextral in nature, after the extension, they are very.
There are dextral faults already. That I am not contesting. But your Kolkata basin, as a boulevard basin between the two dextral faults, it does not fit with this model of boulevard. That is somehow a definition of a boulevard basin. It's a basin already in between two dextral faults.
I have a question. You just go figure 9, just before this slide. And it is very astonishing that the horizontal stress system suddenly changed in figure D. How it is possible? In figure D, it was horizontal, northeast, southwest, northwest, southeast to northeast, southwest, everything is there. Yes. But in between this, how it is changed like that? He mentioned some granitic inclusion or something. D. This deformation, rating change, direction change.
Sir, deformation change is due to the gravity, sir. Induced by gravity.
What is gravity? Gravity is acting everywhere.
It's up to the geological survey of India probably, not after survey.
And the gray tone,
but in the gray color
is major, but it is not in the index.
Is this map prepared by you or it was taken from somewhere?
Taken from district map of
District map of the survey of India?
Yes.
Geological survey.
Geological survey. Survey of India doesn't produce districts. Doesn't produce
Geological survey is
No, it's not there.
What is the gray color?
Gray color.
I think it's
Laterite. This is a laterite. Okay.
laterite blue.
No, blue is only blue is not. The color code change. Okay. Okay, thank you.
Our last speaker in this session is Kamal. You can start your talk, but try to restrict it within a.
Thank you so much. I don't know actually. I'm completely whether befitted in this session or not. Actually, I'm surrounded with lots of geological people, and I'm not from that background. So, and I feel like a small dot with a big canvas. Well, thank you so much. I wish you all a very good afternoon. The present dignitaries, the scholars, dear students. I'm Tamalata, PhD scholar of Department of Geology. Something is happening. Okay. I'm a faculty member of Shulman High College, which is affiliated to University of Calcutta. And today I'm going to present on the importance of petrological analysis in geoarchaeological research in India. But before I proceed further, I would like to draw a precise concept on the interrelationship between the geology, anthropology, and archaeology. As you all know that the geology is deals with the Earth's physical characteristics, substances, and the history and the processes that act on it, whereas the anthropology deals with the human being, including its behavior characteristics and evolution in terms of time and space. And in archaeology, we discover the past remnants of all the anthropogenic activities. So these three disciplines are quite dependent on each other, and all the raw materials associated with the anthropogenic activities comes under the geological domain. Artifacts are made by the humans and the remains are studied in archaeology. Interestingly, the concept of geoarchaeology was proposed by the eminent geologist Sir Charles Lyell and many other geologists, namely Robert Louis Foote, Valentine Ball, Ferdinand Stoliker, and Dean Wardia, Litera Patterson, were firstly contributed in the field of prehistoric archaeology, and thereafter specialized archaeologists were continued their research in this field. So here I have mentioned a quite So quite vast geochronological framework, but we'll limit our study within this part, the Quaternary era, which included the Pleistocene and Holocene, from where the hominid evolution was started and the cultural evolution was adopted and gradually inseminated. And now see what kind of materials that archaeological remains we discover as the evidence of the hominid evolution. There are varieties of prehistoric stone tools made of a number of different other kinds of raw materials, starting from quartz and others here, and some pottery remains, the ceramics, and there's ornamental remains, there's glass bangles and agate beads, and thereafter some building materials and the building and reconstructed, restored of various cultural periods. And here I've mentioned about some of the analytical methods which are used in the geoarchaeological research. Here is the first one, that the lithological analysis. This is a very conventional method to understand the physical properties of the used raw materials, such as color, texture, grain size, and composition. Here are few specimens are given which are made out with different types of raw materials. And I think you all know, I should not mention the type of the raw materials here. Thereafter, the sedimentary petrology. In geological research, we study the pattern of geological succession, composition, texture, and other characteristics of the sedimentary rocks and the cultural deposits within it. You have, I think, if you can see over here, is a hazy type. The picture is showing. The numbers are showing the layers which is unearthed or excavated from the stratigraphy, and these greens things, those are locating the artifactual remains which are attached within the geological layer. So, also this is mentionable that the soil samples have been taken from that layer, and soil analysis, sedimentation pattern, vessel dating are done from these sites. And these are from the Chotnagpur Plateau, and my PhD are on of this. I've already submitted, but I'm waiting for my viva and all. So we have 3 data, vessel dates from this area, which in last ranging from 50,000 to 1,25,000 back, where the hominid evolution was started and continued, and we are the descendants of those people. And here the thin section petrography. The thin section petrography is done on the raw materials on the which of the stone objects are identified, the types of the rocks, and to understand the optical properties in the mineral composition. And those are done in our CU department, Geology department, Calcutta University. And the image analysis, stone tools have been analyzed through the image analyzer to understand the breakage proportions during the manufacturing of the objects. If you know, I have no idea, those stone objects are making from a stone core by heating with another stone. So there are proportion of those particular breakage, and if we can analyze the image, we can understand how it was built at that time, and also we can recover the technology they have used. and also to understand the optical property, and also to understand the decaying characteristics due to weathering process. And thereafter the pigment analysis. I think all of you heard about the rock arts. Well, so and in our India, the Bhimbetka was UNESCO heritage site, and there are more. In Odisha, in Nagpur range, and I've also already visited several rock art sites. Oh, sorry, sir. Actually, it is my second last. Okay. So, for the prehistoric rock art and the color applied on the ancient ceramic, we analyze the mineral properties and composition through the pigment analysis. And then the ceramic petrography for the prehistoric, for the ceramics and terracotta objects, we analyze the soil and mineral composition. So, actually, in conclusion, it might be said that the past anthropogenic activities were depend on the various type of natural resources, as the maximum of the archaeological remains were manufactured either on the rocks or on clay, which are directly associated with the geological properties. With the time, type of raw materials have been changed through the technological advancement as a result of cultural upgradation. In geological research, we always depend on the geological pursuits, even if we try to understand or analyze the archaeological remains or in any conservation or preservation or any restoration works. Till now, many of the geological techniques and methods have been applied, and I have already present here where applied in the research areas. Well, my acknowledgement to Dr. Monroe, Professor and Dr. Saha of Department of Geology, Calcutta University, and also my heartfelt thanks to the organizer of this conference, the chairperson, the legendary seniors of geology, the administrative body of prehistory, Presidency University, presenting scholars and dear students and the audience. Thank you so much. Here I have come not to showcase my work, but to getting some suggestions and the opinions. Thank you.
You talked about, I think, pre-Stone Age.
Yeah, prehistory, and Stone Age.
Stone Age. Yeah. Not in metallurgy.
Actually, bound.
My suggestion, you know one PK Chattopadhyay, Pranam Chattopadhyay.
Yeah.
He did a lot of study on metallurgical side. Basically metallurgy and transit metallurgy. You know him perhaps. I had a collaborative work with your professor also, the head of archaeology. I don't know.
Professor Roy.
I forgot him.
Okay.
So my suggestion, if it is pre-stone and during Stone Age, you don't have any scope. But every metallurgical evidence you get, it becomes immense. You get lot of data from our side, from geology side, and you can collaborate with Geological Survey of India also. It is a suggestion. You can search if you maybe after submitting to PhD.
Actually, sir, the metallurgical area was so limited as the outcome of the calculation is very recent.
But I was tempted to say there is a lot of scope is there.
Yes, and the metal was discovered near about 8 to 7,000, near about 10,000 BC. And whatever we are doing, it is long back. So,
but in we can also provide some mitigation measures. So combine all those web
I'm stopping you, please. Just don't mind. See, as you have told that you were the part of the work of generating thematic maps, mostly using data.
Right.
Am I correct?
Right.
So you should have your conclusions written on that. Even for each individual map, there are some points which should be concluded. Say for example, I am telling you try to prove that aspect map you have done. Why you have done the aspect map? That you have to understand first. Why? Because if it is related to landscapes, then only it is different. Number one, it's slope. Then you should have some analysis with the existing landslides, with the aspect map, with the existing landslides, with the slope categorizations, whatever category you have. So those sort of things should have been there in your conclusion. These are genetic conclusions. These will come after the entire work is over, isn't it? Have you understood?
Yes, sir.
And another
eyes on this field, I think. But you are showing the entire Mizoram.
No, sir. This is the
Only the Aizawl. Still I am telling you, if you want to do the Aizawl district part also, there are huge number of landslides there.
Right.
So the landslide के साथ उसका क्या relations है? That will be a very interesting topic for you.
Otherwise, your conclusion doesn't make any meaning with respect to whatever you are presenting. That in fact is okay.
And another thing, do not explain the theory part. Even the researchers who are here, they also know what is LHP. They also know what is related to it. Do not explain. Do not spend time on that. Everybody knows, these are obvious things, how this slope is being created, how the slope is and one thing I just tell you, your classification you have shown in the slope, 37 to 73, it's a very long classification. That what software you are using? RGS. So RGS give you something of their own. So you have to apply your own knowledge along with the existing landslides to see that under which slope category the landslide populations are more, or we call it spatial association is more. So those classes you have to give importance and you have to reclassify the map based on that. Okay? Thank you. Next.
So before you start, there is an announcement for you all. So the thing is, after we complete this session, we will assemble near Geological Hall for a photograph. Okay, for a group photograph. So they have finished the session. I have also requested them to come over there. So after you finish, please to join us there.
You are late.
No, you are not late. You are doing good work.
Good afternoon, everyone. I'm presenting on geotechnical appraisal and geology at various colony Kolkata, Nagaland. These are the contents that I'll take you through. I'll briefly take you to a brief introduction about Nagaland. Nagaland is a part of northeastern state. It is bordered by Assam in the west, Arunachal to the north, and Manipur to the south, and that shares an international boundary with Myanmar in the east. So Nagaland, geologically Nagaland was formed due to the collision between the Indian plate and the Burmese plate. So this collision gave rise to young active mountain males, and it is subjected to intense and continuous tectonism. So this tectonism it leads to large scale faulting and faulting, and it also caused weathering and erosion. So Nagaland, it has a recurring phenomena in the mountainous areas of Nagaland, and instability it has caused instability, making the area susceptible to landslides. So why is Nagaland susceptible to landslides? Nagaland lies in the 16 zone 5 of the landslide hazard donation map, and one reason is because of its hilly terrain. Another one is because of the weather. During monsoon season, because of heavy rainfall, it also leads to landslides, and because of human activities. So geomorphogeochemically, Nagaland is divided into 4 units, and my study area falls under the inner fault belt. This is a resolved image of my study area, and the name of the study area is called Kolkata. It is in Kohima district, the capital of Nagaland, and it falls under the inner fault belt. The inner fault belt is dominated by the Bisang group of rocks, and this area, while interacting with the locals in the vicinity, it is said that the land it moves by 2 to 3 inches every few years. So, in order to find out the cause of the land instability, the objective was to determine the geotechnical properties of the soil in the affected area. So, keeping the objective in mind, I carried out different methodologies, which include field investigation and laboratory analysis. So, in field investigation, detailed study was carried out to find out the ecology and the soil and water conditions of the area. and soil samples were collected from the affected area, after which GPS was utilized to mark the locations. And after collecting the samples, it was brought to the lab to carry out further testing. The first test was natural moisture content test. It is to determine the water content of the soil in its natural state. The next test is the grain size analysis to determine the grain size distribution in order to find out the size of the grains. The next is Atterberg limit. This Atterberg limit is to determine the plasticity and consistency of the fine grained soils such as silt and clay. It is a set of 3 standardized tests, which is the liquid limit, the plastic limit, and the shrinkage limit. The next test is the shear strength test. Under shear strength test, direct shear method was used to determine the shear strength of the soil. So after carrying out the different testings in the lab, the results of the nature moisture content test was the average moisture content test is found to be 20.9%, which indicates that it indicates high moisture content, which may be due to excessive water in the area. The next is the grain size analysis. This is the result table. So through those tables, we found out that the area, those soils were dominated by silt and clayey soils. And these are the different values of the Atterberg limit test. These are the graphs and charts in support of my results. The plastic limit results and shrinkage limit. So in these shrinkage limit results, we found that samples fall under good, medium, and poor soils. So it varied from poor to good soils. In the consistency limits, we found that some samples showed very steep state of the soil, and then some samples showed either semi-solid to solid state. In the plasticity chart, we found that soils were moderate to highly plastic. This is the direct shear test result. From the direct shear test result, we found that using the raw data software, we found that the soils might have been very weak to weak soil shearing strength and have low load bearing capacity. So in conclusion, the study area is dominated by silt and clay, and hence introduction of excessive water in the area led to the land instability. That's one reason. The other one is the soil in the area consists mostly of inorganic clay of low compressibility and plasticity, with shale as the dominant rock type. So it is weak rock type. And the shear strength of the soil in the area is found to be very weak and have very weak load bearing capacity. So with these reasons, the geotechnical appraisal concludes that it agrees with the field conditions that excessive groundwater and very weak rock type led to the instability of the area. And then here are some recommendations: proper town planning and public awareness campaigns, proper engineering structures, and effective drainage system is recommended to that area. So with this, I conclude my presentation. My references.
Next time, after this, some source stability analysis in some sections. No, I will take out of the other data. So this one clearly.
Good afternoon all. So my name is Department of Geological Engineering, Institute of Agriculture. So today's topic is basically predicting mapping of climate driven conditions susceptibility to GHP and miscellaneous projection for the Eastern Atlantic region. So basically this part is the is a prediction mapping and identified which area is the most susceptible for the solutions in this region. So that is my content, introduction, problem statement, methodology, results, and recommendations. So we also know that solutions is the main natural hazard for India, as in the global government is the 2.4 tons hectare per area, but in India is 16.4 tons per hectare area. So which is more complicated in for the agriculture, productivity and sustainable development and future planning. So geospatial technology is the most promising technique, but in the recent times it is developed for the real-time monitoring, for the machine learning and the deep learning artificial intelligence is the most promising contributions to near real-time processing in the big data analysis. So that's why this is the nobility of the research work. Basically, we will challenging the real-time monitoring of the soil erosion, susceptibility, identify, detect the any regions in the big data in cloud server. So we also produce the novel hybrid machine learning because we also know that multi-variety decision is a traditional and conventional method. So this method we also use with the machine learning method. We also incorporated building apps and real-time judgment in a cloud server. Just like Google Earth in a cloud, this is the most promising recent now also useful. So next we also using for the future projections in the basically in the two climate models, MIRC and ECR model and 2023-2060 future projections of this region. So my study is basically located in the eastern regions in the Birbhum districts in the Durgapur, Shiuri, Bolpur and Durgapur. Basically these regions is the rural of Bengal. We also know that cheetahs are laterite genesis in these regions also. We also know that circulating acid is because this area is the most in the substitute for effective for the denotation process as well as the various types of the process in the soil erosion, stream erosion, as well as the garlic and rabbit. So we also collected the points in the calibration for the GPS survey mapping, handle GPS receiver, and collected the 10 meter by 10 meter and 5 meter to 10 meter. We also collected all of the GPS location of the calibration of the start area 2022-2023 basically in the pre-monsoon season, because we also using for the 5 meter to 10 meter. So we also matching the one of the resolution the resampling technique by the areas multi-sensor data and using for my validation method in the two type of the resampling I also using 5 volt and the 10 volt and 70% for training and 30% for testing. And using for the 0-1 binary composition, 0 means the no gali and 1 means the gali in the probability of 0 to 1. So that is the novel method which I also built in the novel methodology. First we also collected the all the geoenvironmental parameters in 5 subgroups. All the 5 subgroups are divided by the topographical, soil factor, hydrological, terrain parameters and the climatic parameters. Then we also classified by the GHT and weightage. Then we also used with the machine learning methods, and then we also feature selection I also using for the biophysical nature inspired algorithms like the particle swarm optimization, genetic optimization, grain old optimization, height optimization and random fly. So next we also predict the current soil erosion susceptibility map as well as the future susceptibility map. Then we also meeting the sustainable development goal in that link with this methodology. So here I am using for the various multi-sensor data because this is the most challenging. So we are also using for the sampling 5 meter to 10 meter by the downscaling. We are also using all the parameters and the topographical, soil factor, hydrology, distribution factor, and the climatic and anthropogenic parameters. So here this is my result. Basically, we also apply the reasoning method. We are also checking the multi-parameter issue all of the among the parameters. So my results is the highest radiation increasing factor is 8.1 and 1.08 is the Tmax and the runoff. So all these parameters I have no component. So because this is also useful for the further processing. Next we are also using for the feature selection method. So which feature is the most important in this particular area. So I also show all of the biophysical nature inspired algorithm using the best fitness functions using for the hyperparameter tuning by the Python approach, bricks and CV by the Python code. We also write this code and we will also show the elevation distance to river, sand, rocks fragments, geo, runoff, river density, precipitation is the most effective factor in this target basically processing for the evolution of the calibration. So next we are also using for the 5 sampling technique by the random forest, GNMX, 5.0 model environmental extreme drainage position HDB drainage position to Mars and adaptation. So basically very high susceptibility is showing by the Zealand 14.59% in the area as well as the very low is 60.38. So similarly also checking with the in resampling technique using for the 14.18 VDR and as well as the in the 4 class very low to moderate high area in the RGI software by the natural genes method. So where is the basically I show you the 5 there is the 5 resampling result. This is the 10 resampling result. So this is the lesions and red colors means the very high susceptibility and as well as the blue colors is the very low susceptibility. So we also show that most of the eastern region is a very high susceptibility in the basically in the proximity to river as well as the western part of the region. So here is the area of the model baseline model evolution because all of the model are also taking the 5 resampling, 10 resampling. Most of the GBM 10 resampling I am choosing for the best result of my analysis because this is the area under curve 0.9% is the best model accuracy as well as the accuracy 89% and the cover. So we also choose the GBM our most final model. So we also using for the feature importance all the 32 parameters. Basically we also show the elevation, distance, river, precipitations and sand and the runoff. Most of the all of the models also showing the base 50 parameters in a particular game. So next we are using for the future projection of the particular study because this is the most threatening study because earlier current statement also showing this that central part is the most vulnerable. All of the 5-fold and the 10-fold in the SSP 245 and the SSP 585. So because we also take make attention the extension of the threatening of the formation in the center part coastal region. So this is take a make precaution measures. So next we are using for the feature sensitivity analysis, morpho sensitivity, because we also show the distance to river, dam, runoff, and all of the 27 parameters the best selection of the particular area. This rate means is the high sensitivity. We are also checking our GBM model and intersection the distance to river, elevation, soil radiation, and solar radiation. Yes. Yes. So here is the conclusion. So basically we also checking our the nobility. We also use the Fuji HD with the resilient model and using for the nature algorithm model. We also checking the in the study is the elevation is the highest force followed by the nature river, sand or river density. And basically based on the future climate result, so we also taking the necessary result in the secondary coastal part in the most susceptibility soil resources. We also check the nature solution and the soil resilience how to mitigate this type of the future soil erosion. We are also using for the crop resilience and drought tolerance crops and the cover crops and afforestation as well as the using for the local community and policy maker. We also check this issue or this supplement. So this is the event. Thank you. Thank you.
Yeah, the question also. They are doing the lecture so basically
basic part তারপরে আমি এটা আরো জাস্টিফাই করব পরে
আচ্ছা প্রেজেন্টেশন ডেটা শো করে করব বলি তাই এটা হয়েছে আমরা কি আমি পরে সামারাইজ করতাম
একটা জিনিস মনে রাখবো যে যেমন পাবলিকেশনের সময় আমাদের একটা অডিয়েন্স সার্চ করতে হয় প্রেজেন্টেশনের সময় অডিয়েন্স কিছু সিনিয়র লেভেল লোকেরা আছে এক্সপিরিয়েন্স কিছু স্টুডেন্টস আছে কিছু মাস্টারমশাই আছে যারা নতুন ব্রাঞ্চে কাজ করেন তুমি তোমার এইটা 25% দারুণ প্রেজেন্টেশন হ্যাঁ এটা জাস্ট একটা সাজেশন তুমি বলে অ্যাডভান্স স্টেজে পিএইচডি আছো নাকি
হ্যাঁ স্যার মোটামুটি এটা কাজ বেসিক পোস্ট-ডক্টরাল জন্য প্রিপারেশন চলছে
আচ্ছা তো পিএইচডি হয়ে গেছে সেই জন্য আমার মনে হচ্ছে তোমার কাছে প্রচুর জিনিস আছে তোমাকে এই অডিয়েন্সের জন্য যেখানে কিছু লিডিং রিসার্চার আছে কিছু স্টুডেন্ট আছে তোমাকে এমন জিনিস দিতে হবে এই জিনিসটা ওদের কাজে লাগবে বুঝেছো চলো থ্যাংক ইউ
So, we extend our gratitude to all the presenters for their outstanding work and insightful presentations. We also thank Professor Prof Dasgupta and our session chairs, Dr. Shoibal Ghosh and Professor Tapal Chakraborty for their invaluable contributions. Thank you, sir.
We would like to call session chairs to the dais. Before ending the session, we would request our session chairs to present a token of appreciation to our keynote speaker.
So now we will take a lunch break from 2:15 to 3 p.m. Please join us again at 3 p.m. at the poster presentation, and please do not skip the online session which will be continuing at NLT and conference room also from 3 p.m.